Good morning. This is Atlas Centaur Launch Control. Countdown clock is now at T-minus 70 minutes and counting. And we're in the countdown toward the launch of the geostationary operational satellite called GOES-J. This is the second in a series of 5 in a new generation of advanced U.S. weather satellites. GOES-J will be launched aboard an Atlas Centaur 1 rocket from Complex 36B on Cape Canaveral Air Station. This evening's launch opportunity extends for 73 minutes, beginning at 1:41 a.m. and ending at 2:54 a.m. Eastern Time. However, we are going to plan on launching at 1:42 a.m. Eastern Time today in order to avoid changing configuration for the launch of the GOES-J satellite. All countdown events are on schedule for an on-time launch at 1:42 a.m. Weather conditions here in the area are clear for launch, and we have no collision avoidances tonight. A joint NASA industry launch team is on station in the blockhouse at Complex 36 at Cape Canaveral Air Station. Also, members of the management team are in their respective locations at Hangar AE. Right now in the countdown, the launch team just completed filling the Centaur stage with its load of liquid oxygen. We're making preparations to load liquid hydrogen into the Centaur stage. Launch team has also begun chill down for the start of loading liquid oxygen aboard the Atlas rocket. The doors to the concrete blockhouse at Complex 36, the site of this morning's launch, have also been closed and locked. Launch was postponed for several days to allow the team time to go out and inspect the Atlas rocket. The launch attempt was called off because of high winds out at the launch pad area exceeding the limit. Inspection was completed and everything is all set for launch this morning. The Department of Commerce's National Oceanic and Atmospheric Administration owns and operates the GOES series of satellites. NASA manages the design, development, and launch of the spacecraft. Once the satellite is launched and checked out, NOAA assumes command and control, receives data, and generates products and distributes them. We have several videotapes that would be played this morning that highlight the pre-flight processing and describe the launch vehicle and the GOES satellite. Countdown is going very smoothly this morning at this time, and we remain headed toward a launch of Atlas Centaur 77 and the GOES-J weather satellite at 1:42 a.m. We will monitor the activities of the Atlas Centaur 77 launch team until our next report. T-minus 67 minutes and counting. This is Atlas Centaur Launch Control.
Atlas LO2 approximately 25%. Roger.
T-minus 65 minutes.
I and your final line task is complete. Roger, start flight control final preps. Starting final preps. Page 46 is complete. ECSLC. Go ahead. Roger, what temperature are you running in the Centaur thrust section right now?
Right now I'm running at 126, got a set point of 128.
And Roger, your maximum is 130 within parameters, is that correct?
That's affirmative.
Roger, take your temperatures to 130.
Copy, 130.
Atlas LO2 approximately 50%. Roger.
LH2 chill down is complete.
Roger, start LH2 tanking.
Starting tanking.
Start Centaur Pairs bottle charge.
Starting charge.
This is Atlas Centaur Launch Control. We're now at T-minus 60 minutes and counting toward the launch of AC-77 and the GOES-J weather satellite. Launch team has now started loading liquid hydrogen into the Centaur stage of the vehicle. At this time, loading of liquid oxygen into the Atlas stage is now at least halfway complete. Launch remains scheduled for 1:42 a.m. There are no technical issues at this time in the countdown, and weather is not a concern today. We will now play a videotape that describes the Atlas I launch vehicle and the sequence of in-flight events.
The launch of Atlas Centaur 77 will place the GOES-J satellite into orbit for NASA and the National Oceanic and Atmospheric Administration. The second in a series of satellites to be launched by an Atlas, these geostationary operational environmental satellites, built by Space Systems Loral, will significantly upgrade and expand NOAA's capability to provide the data needed for more accurate short-term weather forecasts. The satellite will fly on an Atlas I launch vehicle, one of the 4 Atlas configurations. Atlas I is a 2.5-stage launch vehicle. The Atlas first stage is powered by Rocketdyne MA5 engines. The Centaur upper stage uses 2 Pratt & Whitney RL-10A liquid hydrogen and liquid oxygen engines. Protecting the spacecraft during ascent is the metal payload fairing, available in 11 and 14-foot diameters. A Lockheed Martin payload adapter and separation system will support and then release the spacecraft from the Centaur upper stage. The following profile details the important events of the mission using approximate times.
6, 5, 4, 3, 2, 1. Liftoff of Atlas Centaur 73 with the GOES-I weather satellite. Roll program has started. Pitch program is in.
Shortly after liftoff, Atlas begins its initial pitch and roll maneuvers to attain the proper ascent profile. This will minimize aerodynamic loads.
Chamber pressures look good. We have a smooth flight of the vehicle so far. See the burning or engines burning well, controlling the trajectory of the vehicle.
Booster engine cutoff occurs at approximately 2.5 minutes. The booster section is jettisoned seconds later. For the next minute and a half, the Atlas will be in the sustainer solo phase. During this time, the insulation panels on the Atlas I Centaur are jettisoned. About 30 seconds later, the payload fairing is jettisoned. Burning propellant at a rate of 280 pounds per second, the Atlas will be nearly 92 miles in altitude, 193 miles downrange, and traveling at a speed of 8,270 miles per hour when sustainer engine cutoff, SECO, occurs, immediately followed by Atlas Centaur separation. The MES-1 takes place at approximately 5 minutes into the flight. Centaur and its payload are now in first burn, the longer of the 2 Centaur engine firings. This approximate 5-minute burn will inject the vehicle into a slightly elliptical parking orbit. After first burn main engine cutoff, MECO-1, Centaur, with the spacecraft, enters a coast period of around 13.5 minutes. At a guidance-calculated start time just north of the equator, the Centaur main engines are reignited to burn for just over a minute until the required intermediate transfer orbit is reached. After Centaur's second burn main engine cutoff, MECO-2, the Centaur provides the required separation spin-up and specific pointing attitude. Separation of the spacecraft will occur approximately 3 minutes after MECO-2.
Spacecraft separation. Those separation switches indicate a normal separation.
Lockheed Martin recognizes the importance of GOES-J and its role in Earth and weather observation, and is proud to participate in NASA and NOAA's leading role in the GOES program.
Everything continuing to go very smoothly in our countdown toward the launch of GOES-J and the AC-77 launch vehicle. The liquid oxygen into the Atlas stage is now at 99% as far as being full, and hydrogen into the Centaur stage is now past the 20% mark. Weather continues to be favorable for a launch at 1:42 a.m. Eastern Time today. And we will continue to monitor the launch team as they load the Centaur stage with liquid hydrogen at T-minus 53 minutes and counting. This is Atlas Centaur Launch Control.
Centaur LH2 at 40%.
Roger.
Centaur LH2 at 60%.
Roger.
This is Atlas Centaur Launch Control at T-minus 49 minutes and counting. Just heard that the liquid hydrogen is now past the 60% mark on the Centaur stage. Everything's continuing to go smoothly in our countdown. The terminal portion of the launch countdown started at about 11:40 p.m. at the end of a planned 30-minute built-in hold. And as we came out of that hold at T-minus 90 minutes, a readiness poll of the launch team was performed to verify we were ready to begin loading the cryogenic propellants into the Atlas Centaur vehicle. Tanking activities is being completed with no problems, going as planned. No technical issues are being tracked by the launch team at this time. We will continue to play several videotapes this morning. We'll play a videotape during our next report about processing activities with the Atlas Centaur vehicle, which occurred here at Cape Canaveral Air Station. T-minus 48 minutes and counting. This is Atlas Centaur Launch Control.
Centaur LH2 is off the probe at 75%.
Roger.
This is Atlas Centaur Launch Control at T-minus 45 minutes and counting. Now getting a live picture of one of the weather balloons being released at Cape Canaveral Air Station. Data from the balloon will be relayed back to managers here in the Mission Director Center at Hangar AE. Balloon will give launch managers information about actual conditions in the upper level areas in the flight path that the Atlas Centaur would be taking. The Centaur liquid hydrogen is now past the 75% mark. Things are going well in our tanking activities in preparation for launch today at 1:42 a.m. Just to repeat, we will be holding an extra minute at the hold at T-minus 5 minutes. Hold will be 16 minutes in duration. This is to keep the configuration the same as for the first launched attempt and not to have to change everything for the 1 minute adjustment in the launch window. Window actually opens at 1:41, but to avoid having to change the configuration for launch, we decided to keep the launch time at 1:42 a.m. Processing activities for the Atlas Centaur launch vehicle went smoothly, and we will review processing highlights with about a 3-minute videotape. The vehicle arrived in Florida by a military aircraft. The Atlas 1 vehicle being launched today is one of 4 launch vehicle configurations in the Atlas family, and is capable of launching payloads in the 5,000 to 8,000 pound range to geosynchronous transfer orbit. The Atlas 1 vehicle is about 144 feet tall, 10 feet in diameter, and weighs over 362,000 pounds at liftoff. It will carry the 4,700-pound GOES-J satellite into a geosynchronous transfer orbit with an apogee altitude of at least 19,409 nautical miles above the Earth. Looking at the Atlas stage at this point, being offloaded from the aircraft it arrived in. The stage is brought out to Launch Complex 36 in a horizontal configuration. Looking at the engine configuration down at the aft portion of the vehicle. The vehicle is very slowly and carefully lifted into position out at Complex 36. All processing activity with the Atlas Centaur vehicle went very smoothly. Here we have a nice view of the Centaur stage being hoisted into position. It will be atop the Atlas vehicle. We have the engine configuration on the Centaur stage. Testing was completed. Testing included a wet countdown dress rehearsal, as is normal, which is when the launch team actually fills the rocket with propellant, and they take their positions in Hangar AE and at the blockhouse to simulate practicing for launch. Testing of the vehicle went smoothly. Testing of the vehicle was completed. Many of the tests were completed before the GOES satellite was brought out to the launch pad. Meanwhile, this morning, things are going well out at Complex 36 in preparation for our liftoff at 1:42 a.m. Taking activities are well underway. Centaur stage is being loaded with liquid hydrogen, and the liquid oxygen is now loaded aboard the vehicle. The weather is go for launch at our intended liftoff time at 1:42 a.m. At T-minus 39 minutes and counting, this is Atlas Centaur Launch Control.
LH2 solenoid vent valve checkout is complete.
Roger. Cycle Centaur LO2 fill and drain valve.
Roger. Valve cycled.
Start topping. Start Centaur LO2 topping to flight level.
Starting topping.
LC telemetry, channel 1.
Go ahead.
LC, we noticed some bit toggling on AP529D. It's toggling multiple bits. It appears that this transducer is temperature sensitive. AP529D is the sustainer main LOX valve. It's not viewed as a problem, however, we feel something that might be of interest.
Roger, that was AP529B.
Roger.
How's propulsion, LC?
LC, we're looking into that at this moment.
Roger, keep me advised.
Roger.
Centaur LO2 at 95%.
Roger.
LC telemetry on 1.
Go ahead.
LC, just for clarification's sake, that was AP529D, as in dog.
Roger.
This measurement is not a red line and is used for engineering evaluation only.
Roger's also not an operational limit.
Roger.
LC out's propulsion.
Go ahead.
LC at this time, we have no indication to have any reason to think that valve is opening at all. So we think it's just an instrumentation problem.
Roger.
Centaur pneumatic bottles are at flight mass.
Roger. ALC, LC. Go ahead, LC. Roger. Would you review our situation with Alpha Papa 529 Delta? Roger. And advise.
LH2 at flight level.
Roger.
This is Atlas Centaur Launch Control at T-minus 33 minutes and counting. Everything continuing to go smoothly in our countdown. The Centaur pneumatic bottles are at the flight mass level. The liquid hydrogen in the Centaur tank is over 97% full, and the Centaur liquid oxygen is over 95% full. We did hear the launch team talking about the toggling of a transducer on the sustainer main LOX valve. However, this does not appear to be a problem. It is not a red line situation. Engineers are talking about it, but again, it doesn't seem to be any sort of a red line that we'd be concerned with for launch tonight. Used for engineering evaluation as a point of instrumentation. Just past the 32-minute point in our countdown. We will now play a short videotape of processing activities of the GOES spacecraft at the Astrotech facility in Titusville. The GOES spacecraft arrived also by military aircraft in the Florida area, and the processing occurred over at the Astrotech facility in Titusville. The GOES-J was built by Space Systems Loral of Palo Alto, California. NASA's Goddard Space Flight Center in Greenbelt, Maryland is responsible for the GOES project management. Kennedy Space Center is responsible for government oversight of the launch vehicle processing activities. And Lockheed Martin Astronautics of Denver, Colorado is currently under contract to Lewis Research Center to provide the Atlas I vehicle and associated launch services. For the first time, the United States will have 2 advanced geostationary weather satellites providing coverage of the United States and adjoining oceans. This will result in improved weather forecasts and could save countless lives and dollars. For the past 20 years, the GOES satellites have been the National Weather Service's observers of weather and tropical storms. With the launch of this particular GOES satellite, this is one of the most essential elements of the National Weather Service's modernization and associated restructuring program. These satellites provide meteorologists and hydrologists with detailed weather observations and measurements, more frequent imagery, and new types of atmospheric soundings. We'll have more capability to have 1-minute imagery over small areas. This will provide a tremendous new capability of observing severe weather that has never been seen before. Local and coastal fog conditions can be detected. The GOES spacecraft was put inside the fairing, the nose cone-shaped component of the spacecraft. Was hoisted high above at the launch tower so it could be moved into place and mated to the very top of the rocket. See the NOAA emblem on the exterior of the nose cone portion of the rocket. All processing activities for GOES were on schedule for the launch this morning. No problems were tracked with that particular spacecraft. The liquid oxygen is now at the flight level in the Centaur vehicle. And the two weather balloons have been released. The Gemisphere and the Raywinson were launched on schedule to feed data back to the launch directors here at Hangar AE at the Mission Director Center. Just past the 28-minute mark in our countdown. Again, all events on schedule, no technical problems being tracked today, and weather is clear enough for the launch. Does not seem to be an issue this morning. Looking for a launch at 1:42 a.m. This is Atlas Centaur Launch Control.
T-minus 22 minutes.
FTS signal strength test is complete.
Roger.
LC, Centaur Pneumatics, Channel 1.
Go ahead.
Roger, LC. It seems that we have our insulation panel for Delta P, CFV047P, has dropped out.
Roger, the measurement has dropped out.
Roger, we were reading approximately 0.24, and it dropped down to 0.009.
What is the operational limit on that?
The operational limit is read off of CA 1488 Peter, which is still reading approximately 0.28.
Roger, so you have one measurement that indicates that you still have your delta P.
Roger, LC.
Instrumentation, LC.
This is instrumentation, go ahead.
Roger, would you take a look at CFV047 tier?
In work.
This is Atlas Centaur Launch Control at T-minus 18 minutes and counting. We now have the liquid oxygen, liquid hydrogen tanks full for the Centaur and Atlas stages. The Atlas first stage burns liquid oxygen and RP1, a highly refined kerosene. The Rocketdyne MA5 engine system with 2 booster engines and 1 sustainer engine combined for a total thrust of 439,300 pounds at liftoff. The Centaur's second stage burns liquid hydrogen and liquid oxygen. 2 Pratt & Whitney RL-10 turbopump-fed engines produce 33,000 pounds of thrust. We have a single hold remaining in this morning's countdown, and it comes at the T-minus 5 minute mark. That hold will last for 16 minutes today. Again, we are launching at 1:42 a.m., which is 1 minute into the window. And we did this as a matter of convenience for the team, that not to have to reconfigure from the 1:42 a.m. timeline, just 1 more minute. The window actually opens at 1:41 this morning, but we remain headed for an on-time launch, 1:42 a.m. A signal strength test of the flight termination system was completed. We'll continue to monitor the conversation of the launch team until our next report. T-minus 16 minutes and counting. This is Atlas Centaur Launch Control.
Roger, again, our situation is you can identify the flow going to the panel. You can read the pressure at the top and not at the bottom, is that correct?
That is correct.
ALC. Go ahead, LC. Roger, assume you've been copying channel 1. Would you convene the anomaly team and look at those measurements, CFV047P, CA1488P, and CN1565R? Roger. Instrumentation, LC.
This is instrumentation, go ahead.
Roger, have you been able to scrutinize that measurement, CFV047P yet?
We see it on Adams.
Roger, do you recognize any characteristics? Is it real data, a failed transducer, of that nature?
We're still looking at it, sir.
Roger, keep me advised.
Yes.
There'll be a final weather briefing on channels 20 and 24, T-minus 14 minutes.
the winds would be a problem. Vehicle exposure, again, no chance of lightning, and the 10% right now is again focusing on the end of the window and beyond. Right now we are 0% chance of exceeding 22 knots at the beginning of the launch window. No change to the overall forecast, still at 10%, but keep in mind at the beginning of the window at T0 we are at 0% chance of violation. This 10% is now confined to the very end of the launch window. That concludes my T-minus 14-minute weather briefing. Just to point out, we are green on all launch permit criteria and expect to remain green at the beginning of the window. Are there any questions?
Joel, the showers to the east and north of us, what are the tops on those?
The top, to answer the first question, the tops of that cell, the closest one right now is only 11,000 feet. And again, we are going to monitor it to see if it grows any further than that. And what was the second question? I didn't catch that. Can you say again, please?
Okay, that was my only question. But
say again, Sue. I'm getting multiple questions at one time. One more time, please. Negative, sir. We do not expect heavy winds with that single cell. If we expect any winds at all, would be with that line. And again, that's 2.5 hours away.
LC range coordinator, go ahead. The FCO said that during the self-test they received a severe toggle on the AGCs. They do not understand this and would request that we form an anomaly team.
Roger.
T-minus 10 minutes.
LC, this is FTS on Channel 1.
Go ahead.
Yes, sir. We were contacted by OSM on Channel 5 just moments ago, and we're calling up the date on Adams at this time.
Roger. Start fuel depletion final checks.
Roger.
Start purge pressure switch check and purge bottle topping.
Roger.
This is Atlas Centaur launch control at T-minus 9 minutes and counting. Counting down to the hold at the T-minus 5 minute mark. Again, that hold will last for 16 minutes. We did hear that a verification of the fuel depletion sensors on the Atlas RP1 fuel tank are working properly, and we're getting a wet indicating that we have a full tank. Again, the RP1 is a highly refined kerosene. Purge bottle topping and verifying that the purge pressure switch has begun. And pitch and yaw programs have been received and loaded into the inertial navigation unit and verified. The pitch and yaw programs are kind of a road map that is loaded into the guidance computer to tell the vehicle how to steer itself to the right orbital path. Weather continues to be green for the launch today. We've got just a 10% chance that we would have unacceptable weather, and that appears that the 10% is forecast for the back end of the window. Again, we do expect an on-time launch today at 1:42 a.m., just past the T-minus 8 minute mark in the countdown. We will enter the hold at the T-minus 5 minute mark. And the purge bottle topping is complete, and the Centaur fill and drain valves are being cycled. We'll be getting verification that the cryogenic propellants are at flight level. T-minus 7 minutes, 30 seconds, and counting. This is Atlas Centaur launch control.
Switch secondary PCM decom and secondary Adams to RF link.
Secondary decom and Adams on RF link.
Fuel depletion final checks are complete.
Roger.
Final Centaur vent valve cycling is complete.
Roger.
Minus 6 minutes, 30 seconds.
Cycle Centaur LH2 fill and drain valve.
Roger. Atlas LO2 at flight level.
Roger.
Centaur LO2 at flight level.
Roger.
LH2 at flight level.
Roger.
This is Atlas Centaur launch control at T-minus 5 minutes and holding. Again, this is a planned built-in hold, normally 15 minutes. We will extend it for 1 additional minute to launch at 1:42 a.m. During this hold, the final cycling of the Centaur vent valves will be completed, and the vents to the blockhouse will be sealed to protect the launch team from smoke and vapors of launch. The Atlas Centaur rocket will put the satellite into an elliptical or egg-shaped orbit with a high point of about 19,400 nautical miles and a low point some 90 miles above the Earth. We will now play a brief videotape of the tower rolling back away from the launch vehicle. Several hours ago, the launch tower was moved away from the Atlas Centaur 77 vehicle in preparation for the launch this morning. We have views from inside the blockhouse, Complex 36. See the American flag displayed. Engineers monitoring consoles, monitoring the vital signs of the launch vehicle from inside the blockhouse. Launch team, of course, is on station at this time. And this was during the tower rollback activity, which was several hours ago. GOES satellite weighs about 4,700 pounds at launch. The weight at liftoff of the vehicle will be about 363,000 pounds. We're at Pad B at Complex 36 with the Atlas 1 launch vehicle. We've got a standard Atlas 1 ascent profile planned for this morning. Spacecraft separation will occur about 29 minutes into the flight. The inclination is 27 degrees. Again, the expected apogee and perigee for the GOES satellite would be about 19,500 nautical miles or greater, and the perigee would be about 90 nautical miles. All's going very well in our countdown. It's quiet in the Mission Director Center. Later on in this hold, we will get a final go. We will hear members of the launch team being polled, and we'll listen to that. We'll monitor the launch team in the final minutes of our built-in hold, and as we come out of the hold, we'll be providing live coverage of the launch and the in-flight sequence of events.